Welcome to the solvent-free Aldol condensation lab at Tacoma Community College. In this lab, we will combine one indinone with 3,4-dimethoxybenzaldehyde and sodium hydroxide to create an aldol condensation product. The first step in an aldol addition or condensation reaction is to identify alpha carbons. We have an alpha carbon here, here, and over here. However, the only alpha carbon with protons is this position right here. So that's the position we're going to be interested in. I'm going to erase these over here. And we know that this position is going to have fairly reactive protons because they're the most acidic protons in the molecule. That means if we have a base present, the base could grab one of these protons and deprotonate. When we deprotonate that position, we create something called an enolate. An enolate has resonance delocalization, so this negative charge that we formed can delocalize all the way up to that oxygen, thereby stabilizing it. However, the carbanion form, where the negative charge is on carbon, is going to be the form that we're going to be using in the next reaction. This carbanion is fairly nucleophilic, and it can attack the electrophile in our aldehyde. So if we show this mechanistically, we can show the negative charge attacking in and kicking electrons up to that oxygen. This gives us a negatively charged intermediate. This negatively charged intermediate isn't that stable, so it will grab a proton from our conjugate acid from step 1, which in this case is water, and we will form a neutral organic intermediate. This neutral organic intermediate is just our aldol addition product. And as you can see, in this step where we grab the proton from water, we also regenerated hydroxide. This hydroxide will continue to react if temperatures are high enough or if conjugation can be extended. So it will go after this second alpha proton. However, instead of forming an enolate, what it can do is clamp down and eject off hydroxide. In this case, hydroxide is essentially acting as a leaving group. It's fairly uncommon in organic chemistry, but it's outweighed by the fact that we're making something that's energetically a lot more stable. So let's take a look at what is formed in this next step. In this last step, you can see that we formed a new double bond right here. This double bond is energetically favorable because now we have extended conjugation through this aromatic ring system off to the right, and we have a p orbital system going all the way to the left too. So we essentially have aligned p orbitals through both rings. This is so energetically favorable that this last step, where we go from the aldol addition product to the condensation product, occurs without any additional heat. When we do this, you can see that we kick off hydroxide as a leaving group, meaning that it's catalytic. We put it in the beginning, we get it out in the end, and we also generate water as a byproduct in the reaction. Anytime you kick off water, it's referred to as a condensation reaction. All right, so let's see how this is done in the lab. All right, so the first part of this experiment is to get your bottle of 3,4-dimethoxybenzaldehyde and measure out about 0.25 grams of it. So let's go ahead and do that. It's a little tricky because it is quite clumpy. So I'm just going to pull out a few clumps and see if we can get right in that ballpark. Halfway there. Do another nugget. Getting closer. Almost there. Oh, look at that. Exactly 0.251. All right, so now that I have that ready, I'm going to go ahead and put that into my test tube. Alright, the next reagent I need to get is my 1 indinone, and I need to measure out about 0.2 grams of that. So let's go ahead and do that carefully as well. bit more. Alright, so it looks like we're at 0.201 grams of the 1-indinone. Now let's add that back to our test tube. The next part of the experiment is pretty unique. You can tell right now that this combination of powders looks to be white and fairly homogeneous. What I'm going to do next is I'm going to grab my spatula and I'm going to try to mash this up into an oil. So let's go ahead and try that. I'll do my best to get it into the camera. Alright, so at the end of this mashing procedure, you can see that I've got this nice kind of yellowish oil. The next thing I need to do after I've created that oil is to add my sodium hydroxide. So let's go ahead and measure out our sodium hydroxide. Alright, so the sodium hydroxide we're using is ground very finely, so we have to keep it in this desiccant chamber to prevent any of the moisture in the air from getting absorbed into our sodium hydroxide. Sodium hydroxide will actually react with the CO2 and moisture in the air and neutralize the carbonic acid that's formed. Alright, so here's what we need to do. We need to do this quick, and we need to measure out about 0.5 grams. Looks like we're already there. So I'll go ahead and transfer this over to my test tube really quickly. Alright, so I just added the sodium hydroxide to my test tube. Now what I need to do is I need to continue mixing the content of the test tubes until it becomes kind of this solid goo. So I'll go ahead and do that, and then I'll show you the final product here in a second. Alright, so I've been mixing for a while, and you can tell that at this point there's really not any liquid left. Everything's kind of this thick, gooey paste. In fact, if I pull my spatula out, you can see it sticks to my spatula pretty well. And what I'm going to do is I'm just going to let this sit in my test tube rack for about 15 minutes before I continue on with the experiment. Alright, so my product's been sitting in the test tube for about 15 minutes, and if we look at it one more time, it's quite clumpy. In fact, when I go ahead and try to mix it up, it just feels kind of like chalk almost on the inside, which is good. We wanted our product to become kind of chalky and solid in consistency. Alright, so I've got my chalky solid in there. It's nice and yellow. What I need to do next is I need to add 2 milliliters of hydrochloric acid to neutralize the solution. And in particular, we're going to use 10% HCl, so it's not very concentrated. And I'm just going to add 2 squirts. I know my squirts are about 1 milliliter. Alright, so I've got my hydrochloric acid in there. Now I'm going to try to mix this all around, because I know some of that sodium hydroxide could be kind of lodged on the sidewalls or in that solid product. So I'm just going to go ahead and try to briefly mash this together, and then we'll check the pH here in a second to see if the pH is in fact acidic. Alright, so I've mashed it up pretty good. I've got this kind of, I don't know, heterogeneous mixture of yellow powder in this clear solution. Let's check the pH. Alright, And with pH paper, remember we always want to grab it with our forceps or tweezers. I'm going to move this a little bit. I'll use my glass stir rod, dip in, and then just touch the paper. And as you can probably tell, the paper is nice and red, which means it's in fact acidic. So we're ready to go on to the next step. Alright, so we've got our solution neutralized now. Now the next step I want to do is I want to filter out all of that solid gunk. So what I'm going to do is turn on my vacuum filtration setup. I'll check to make sure the vacuum's on, which it is. I'll put my piece of filter paper inside, and then I'll pre-wet that filter paper to ensure that I've got a nice tight seal. Alright, now what I'm going to do is I'm going to try to get all of this solid to transfer out. And I have a second spatula ready to help kind of get the gunk off the first spatula. It's actually harder than it looks to get all of that off. Alright, so I got most of it off the spatula. Now what I want to do is rinse this out a couple of times and try to get all of the solids out of the tube that I can. Alright, I'll do one more rinse. Can't get all of it, but we'll get as much as is reasonably possible. Alright, so now we'll let that air dry for a few minutes, and then we'll get the crude mass and try to recrystallize it to get our pure product. Alright, the next thing I want to do is I want to tear a small Erlenmeyer flask and then get the mass of my crude product. So let's go ahead and do that. The crude product is a yellow powder. I've got it on a piece of whey paper here. And I'll just dump all of that kind of clumpy yellow powder to the inside of this small Erlenmeyer flask. So that's my crude product. Let's see what the mass is so we can record that for our lab data. So it looks like 0.473 grams is the mass of our crude product. Let's go ahead and recrystallize that using 90% ethanol and water. Alright, so now what I'm going to do is I'm going to get ready for my recrystallization. What I've done is grabbed a small bottle of 90% ethanol, 10% water. I put that in a small Erlenmeyer flask on my stir plate and I brought it to a boil. In a separate Erlenmeyer flask, I have my crude product, and what I'm going to do is I'm going to transfer some of the boiling ethanol into my product. And then I'll put them both on the hot plate together. Right, the goal with recrystallization is to create a supersaturated solution. So what we're really looking for in our product flask is for all of the solid to dissolve while boiling. If it doesn't dissolve, we need to add more ethanol. I'm going to try to break up some of the clumps too by using my spatula, since some of them are rather large. And I'm going to add some more ethanol. looks like we still have a fair amount of clumps, so I'm going to go ahead and add a little bit more. We'll see if we can get all of those solid clumps to dissolve. Alright, it looks like most of our solids have dissolved, but there's still a few big clumps in there. So what I'm going to do is I'm going to take my Erlenmeyer flask off of my stir plate, and I'm going to transfer the hot liquid to a clean Erlenmeyer flask, but I'm going to avoid all of those solid chunks. Alright, and now that I have that sitting in there, I'm going to let it cool to room temperature. And then after that, to encourage crystal formation, I'm going to put that in my ice bath. So let's wait a minute for it to get to room temperature. Alright, so our solution's back down to about room temperature. You can see that we had some solid kind of gunk in the bottom of the flask. I'm honestly not sure what it is. There's some gray chunks. But we did a good job of pipetting away all of the liquid and avoiding transferring the gray chunks to our recrystallization flask. At this point, what we want to do is just set it in our ice bath. And I might add a little bit more ice and water and then let that sit for about 15 minutes. Alright, so one other thing I can do while waiting is I can get the top off of my Buchner funnel, grab a piece of dry filter paper, and get the mass of both of these. So I'm going to go ahead and pre-weigh both of these. That way when I'm done vacuum filtering, I can just put it back on the scale and record the new mass. So let's go ahead and get the new mass, or sorry, the original mass, which is 11.666. Alright, so my recrystallization has been in my ice bath for about 10 to 15 minutes, and during that time I also put my ethanol solvent that I use for the recrystallization in its own ice bath. We want to make sure that we use cold solvent when doing vacuum filtration. That way we don't dissolve any more of our product than we need to. Alright, so what I'm going to do is turn on my vacuum filtration setup. I'm going to double check that the vacuum's still on. And then I'm going to use my ethanol over here to be my solvent for pre-wetting my filter paper. So I'll go ahead and add the solvent until I hear that nice hissing noise. Alright, so I hear the hissing noise. That means I've got a nice tight seal. I'll just double check. And then what I'll do is I'll grab my product, which you can see is nice and thick with crystals. Wipe off any water. Not really supposed to use your lab coat, but you get the idea. And then dump all of my product through the vacuum filter. And then I'll use just a tiny amount of cold ethanol to rinse my flask to ensure that I get all of my crystals out that I can. You can never get 100% transfer, but you can do the best that you can. So right there, it looks like my flask is pretty clean. I'm going to set this to the side, and I'm going to let everything air dry for just, I don't know, 5-10 minutes. Try to get it as dry as possible, and then we'll put it right back on the scale. We'll get the mass, and then I'll go ahead and get the melting point. We should be able to determine if we made the product, and if so, how pure it is. Alright, so I just pulled my product off of the Buchner funnel, and you can tell it's kind of a yellowish, off-white yellow, fine crystalline powder right now. What we're going to do is we're just going to put this right back up on the scale and subtract the mass that we determined before for the Buchner funnel and the filter paper. Alright, so it looks like our new mass is 11.956. So let's record that for our lab data. Alright, so the last part of this experiment is to determine the melting point range for our final product. I won't force you to watch this, but the expected melting point range is 178 to 181. So after this video, what I'll do is collect the data and then report it back to you. Alright, good luck with your lab report.